Our final speaker this afternoon is Aaron Breimer. Aaron is an experienced agronomy professional and leader in agricultural science. He grew up on a farm in southwestern Ontario and holds a Bachelor of Science in Agriculture from the University of Guelph, where a semester exchange in New Zealand sparked his passion for soil chemistry. Aaron began his agricultural career in retail agronomy and earned his CCA designation in 2003. He is currently principal at Moose Ag, a high-definition topsoil mapping and agronomic data service. Aaron is here today to talk about all the layers of data you have on your farm and can be used to make smarter, more profitable decisions for your farm. Aaron? There, just put it right on there.
Okay. Sounds good. Okay. All right. Thank you very much for having me. As mentioned, I'm from Ontario. We'll get into that in a second, exactly where I'm from. So, Moose Ag. Everybody asks me where Moose Ag comes from. You heard in the introduction, I had an opportunity to study in New Zealand. While in New Zealand, I took up playing competitive rugby. Never played rugby before in my life. That'd be a great way to experience the culture. My rugby teammates did not know much about Canada, but they knew we had moose, or mooses, or meese. Anyway, the long story short, my nickname became Moose. And my time in New Zealand, you heard in the introduction, really introduced me to the idea of soil chemistry. So naming my company Moose Ag was a shout out to my friends in New Zealand on that. Through my career, I've had a lot of interesting opportunities, including working in sub-Saharan Africa on subsistence farming. We heard from Stuart earlier this morning, his time in Kenya. This is in Zambia. In Ontario, I'm so famous, they've given me a provincial park. Joking, it's not named after me, but when I heard it existed, I had to go get the picture because, well, you know, you gotta. I'm an avid scuba diver. I throw this out there because when we get into the Great Lakes and phosphorus loading, I've got a vested interest. This is me actually in Great Lakes on a shipwreck. Take one look at me, you know that I like to eat. I also like to cook. I am a data agronomist, so believe it or not, you're gonna have a hard time believing this. I don't walk a lot of fields, okay? But I like to look at a lot of fields through data. I have one employee, and he's my chief morale officer. Meet Antler the border collie. He doesn't like swimming. All right, this is where I'm from. That white outlined area is the area that I primarily serve. I do some stuff in the States and a couple other provinces as well, but that's the majority of it. And that little yellow pin, that's Chatham, Ontario. So you can see I'm about as far south in Canada as you can get. In fact, I was checking the weather forecast. By the end of the week, we're going to be 18 degrees Celsius. Yeah, and I get to be in PEI. That was smart. All right, I told you I'm a data agronomist. So I've been an agronomist for 25 plus years. I grew up on a farm, so I'm the farm kid as well. And so this is how I view decision making as far as an agronomist. And this is how I do it. It's not just based off my gut and my experience. Because of precision ag, we've got all of this data. And I promise you, this presentation does not go into, well, this platform does this and this platform does that. No, I'm going to share with you some real world examples of what I've been able to get out of the data for the clients that I work for. It might work for you, it might not. But the idea is to get you thinking about how you can test it on your farms. In 2019, I had an opportunity to present at Develop with Deere. This is a giant conference. They bring every John Deere dealer across North America, a bunch from South America, a bunch from all over the world. And anyone who's working with Deere, the Ops Center, we get invited to present to them on what we're doing. And so I took the opportunity to ask the Deere dealers, what's limiting precision ag adaptation? And this is their word cloud. This isn't what I came up with. But you look at that, And I guarantee you're looking at those words and you're like, yeah, that makes a lot of sense. And that is actually with a lot of things in agriculture. ROI, cost, time, knowledge, ease of use. All of those things are recurring. So ag has many solutions looking for problems to solve. We heard of some of them today. There's a bunch of them. I guarantee I can probably spend 45 minutes going over all the different possible solutions that exist out there. Basically, it's everything that the industry knows that farmers need. But farmers are like, yeah, I don't know if it really has a fit. Or they're not sure where the fit is. So there's one exception to this when it comes to ag technology. Guidance solutions. Farmers love guidance solutions, right? Because I don't want to say it makes your life easier, but ultimately it makes your life easier. It allows you to do more things, right? Stuart was talking about this, right? Good luck checking your Twitter account if you don't have autosteer, okay? I'm joking. But it allows you to communicate better. It allows you to spend more time out in your fields without being as tired. It allows you to be more accurate in application. Guidance is one of those things that has really jumped what we call the chasm risk. And so what the chasm risk is there's a bunch of people in this room, I guarantee it, that they're the innovators. They're borderline mad scientists, right? That are constantly trying to figure out new and weird things. Good luck trying to keep up to them. They're like squirrels on caffeine. Their mind's going to a million miles an hour. Then you get into the early adopters, and they want to try anything new that's coming out. But it's the early mass that projects struggle to go from those early adopters who want to try everything new to the early mass, and these are large farmers, and the reason they become large farmers and very successful farmers is because they're watching and they're like, okay, if that makes sense, I'm going to do it. They're not going to be the first ones to do it, but anything that makes sense, they're going to jump all over that. Okay? So like I said, there's this chasm risk that we run into. I love this curve. I just love it for the names, right? Like peak of inflated expectations, trough of disillusionment, right? Slope of enlightenment. All right, I've got 6 lessons to share with you guys today. First one, make it easy. Okay? If it's not easy, it's not going to happen. Okay? So you've all seen the easy button. It's very, very important. So let's talk about precision ag. Here's one of the very first fields that I worked with on variable rate, and it was a variable rate corn field. Now, where do you think the highest yield is, right? I know you guys don't like putting your hands up. We've already been through that, so I'm not actually going to expect an answer. But if you look at the yield map, you can see where it lines up. Obviously, we've got some fairly significant eroded knolls here, and really got high organic matter in between. This is actually it's a chicken farmer. So the fertility has a lot to tell this story to it. So when you look at that and you start thinking about variable rate management map, this is actually one of my dad's fields. I mentioned I'm a farm kid. And this is actually using satellite imagery to identify high yielding and low yielding fields. You can have 2 approaches depending on what you're doing. You can put a higher seeding rate on your best soil and a lower seeding rate on your less productive soil. This is quite often the approach that we take with corn. However, with just about every other crop that I've played with, we reverse it. That the best soil gets the lower seeding rate, and the worst soil gets the higher seeding rate. This is soybeans, this is edible beans, this is wheat, all kinds of crops like that. All right, I'm going to show you how I've gone through the process of learning to analyze if variable rate actually makes money. First attempt was the standard side-by-sides. This is what every farmer does. You've got a prescription, you turn the prescription on and off, right? So you get these check strips scattered throughout the field. Except this one. This one, you forgot to turn it back on, right? Because you were talking on the phone to your favorite data agronomist, and you got pretty excited and you forgot to turn it back on. So we ended up with this oopsie. Now, you've got a lot of things going on. So are you actually going to do that in every field? Probably not. So in attempt number 2, what we did was we pre-programmed it. Planter's 60 feet wide. We know what side of the field he's going to start in. We go and put those strips exactly in there. It makes life super easy for them. The problem is, depending on where you put that strip, you can guarantee yourself a win or you can guarantee yourself a loss. It really depends on how much of high productivity versus low productivity and what's on either side of it. So trying to get this to be representative, next to impossible. So, tip number 3. Now we're going to throw in a whole bunch of replications, okay? Tiny little check blocks, 60 feet by 60 feet in this case. Don't recommend 60 feet by 60 feet. You run into all kinds of other data headaches, but it was the start of the idea. These things are awesome. They're pre-programmed, representative, lots of reps, blah, 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 blah. And you get a whole bunch of numbers. I'm a numbers guy, right? Eric Richter and I have known each other for quite a while. Eric will tell you, yeah, he's a numbers guy. But if you look at all those numbers and you're like, did I make money or not? Well, yeah, I can figure it out for you, but it might not be intuitive for you to see it. So what we started doing was creating these response curves. So taking all this data and basically creating a line of best fit. And then you could see where you were seeding that field and be able to see if you were making money. Of course, farmers are like, okay, that makes a little bit of sense, but where does it make money in my field? So that's when we started integrating them back into the maps themselves. What am I doing for time? Okay. So it makes it very easy to see, hey, this is where you're making money, and this is how much money you're making. So once again, it was to make life easier for farmers. I thought I was off to the races with this. Working with large clients, they want to see this the first year or the second year. After that, they just want to see a summary. Did I make money or did I make money? That's what they're interested in. So for agronomists in the room, make your client's life easy. Always be willing to learn. I thought I knew how nitrogen worked. So I went out and said, okay, I want higher yields. I need more nitrogen. So I went and put more nitrogen in the high yielding areas. But I put in all my check blocks, and lo and behold, it was the exact opposite. Now, we've heard a couple speakers, including Brian, and if you think about what he was saying, your best soils are quite often the highest organic matter. That's where it's going to mineralize the more nitrogen. You don't need more nitrogen there. This is counterintuitive to how a lot of agronomists think. And if you say, oh, no, that makes perfect sense. Yeah, that's because we've stumped our toe and we've figured this out. But every year, because I actually do write variable rate prescriptions and I support other agronomists, every year there's a new agronomist that comes along, asks me to help them. I recommend this. They're like, no, I want to do it that way. Okay. And lo and behold, we get to learn the lesson again. All right. Lesson number 2. I love this one. My father emigrated from Holland in 1974. Okay, so that makes me first generation Canadian with a Dutch father. I'm not sure about in PEI, but in Ontario, we have some Dutch jokes. You guys have Dutch jokes here? Yeah? You know what, right? What are the 2 main characteristics of the Dutch? Right? Cheap and stubborn? Sound about right? You guys are still not putting your hands up? Here's your chance. Or maybe you're all Dutch. Okay, stubborn and cheap. We are not. We are thrifty and right. Get over it. So let's make money. I've been at this variable rate thing for about 15 years. I've done a pile of acres. I haven't made money on every acre. However, when I take my long-term average, here are the numbers, right? So corn, I've been at it for 14 years. On average, it's about $7.51 an acre. It's not huge. Soybeans, better, $14. Nitrogen, $11, just under $12. Edible beans, so this is your kidneys, your whites, things like that, $28. Fungicide, $16. For PEI, this is gonna blow your mind. Wheat, variable rate wheat. I did not think this one was gonna work, and that's why I've only been doing it for the last 5 years, because I was convinced this was dumb. And boy, oh boy, did Mother Nature and the data prove me wrong. Over $30 per acre with variable rate wheat. Planting a little less seed in the best parts of your field, and a lot heavier seed on the top. When I'm working with variable rate corn, I'll work with a range of, say, maybe 30,000, unless I'm dealing with real sharp sand, maybe 30,000, and on an upper limit, maybe 37,000, not much higher than that, unless I'm dealing with silage, and then I might go to 40. But with wheat, I'll run a wheat rate from about 800,000 to 2.2 to 2.4 million seeds per acre. It's a huge spread that I'm running. So variable rate wheat, if you guys want to try something initially, it works great. The other thing that I'm working on, and I don't have good data to share with you yet, is how these things stack on top of each other. So for example, with edible beans, what we're doing is variable rate edible beans with variable rate nitrogen and a selective fungicide. So selective fungicide is just on and off. And in the case of this, it is basically going after white mold. All right, some other technology that makes money that I love to share. Okay, automatic row shut-offs, right? Let's face it, that just looks pretty, right? You drive by and you see that on your neighbor's field, you're like, wow, they're a good farmer, right? Because it just looks gorgeous. Until the automatic row shutoffs don't work and then you got gaps everywhere. But honestly, they look great. The question is, and I was challenged by an equipment dealer, does it make money? Obviously, you're saving seed by not double planting, but does it do more than that? So there's some factors that increase overlap. Obviously, field shape. My dad does not own a square field to his name. Size of the planter, everything's getting bigger and wider and longer. Speed of planting. Speed of planting is interesting because it's tied to the risk of rain. And I've got lots of cases that show what the speed map happens in the field right after the noon weather report. Planting progress versus data. I love this one because people are like, oh, I don't plant too fast. And I take a look at what their average planting speed is on their first field where they're trying to prove me wrong. And then I take a look at their last planted field. Yeah, we're talking about 1.5 miles faster. I'm like, yeah, I thought so. Patience, or in the case of my father, lack thereof. All right, but this is the question. The 60,000 nubbins, okay, you guys know what nubbins are. There's the small cobs where you overlapped, equal 30,000 cobs. So we forced an overlap, and then we went in and we harvested 1/1000th of an acre. Here's the numbers that we got going all the way back to 2011. You have about $100, $125 an acre in savings in seed. The rest of this is yield loss. So there is a significant yield loss. And then, of course, someone decided they didn't like their summer students. And in 2013, 2014, we actually did it with soybeans. And we've seen the same thing with soybeans. That if you plant too high a population, they make a great forage crop. Actually, soybeans were originally introduced in North America, right, Eric, as a forage crop. I think you might have been the one that taught me that, Eric. Moose egg lesson number 3. Challenge what you know. Okay, what part of the soybean plant is most important for yield? All right, Eric. I've known Eric for a while. What do you think, Eric? Bottom part of the plant, middle part of the plant, or top part of the plant? What's that? Too long. All right, I will tell you, I have gone out and I have counted a pile of soybean pods per plant. And you can see this, in 2011, I counted on 535 plants and I graphed out where those pods were on the plant. And in 2012, I was really nuts and I did over 4,000 plants like this. And I graphed it out. And what you will find, if you go out and look in your soybean plants, is on the first node, you'll have 1 pod. Second node, 1 to 2 pods. And all of a sudden, the third node, all of a sudden you start seeing 3, 4, 5, 6 pods per node. This will happen for the next 2 or 3 nodes, and then all of a sudden starts to drop off again. And when you get to the top part of the plant, where everyone's like, oh, look at that top cluster, that's gonna make me lots of money, you're down to 1 or 2 nodes, or 1 or 2 pods there again. Yes, you do have the, little blip at the end that comes back up, but for the most part, it's earlier in the season. That's when you want to be saving, trying to save soybean flowers and pods. So this was something that I worked with around fungicide So if you can have one extra bean per plant, not a pod, just one bean, and you have 165,000 plants per acre, and you divide it by 2,750, 60 pounds or 1 bushel. So one extra bean, not an extra pod, equals 1 extra bushel. It doesn't take, that's the great thing about soybeans, is if you can unlock how to save an extra bean or an extra pod, you can really start to multiply it out, right? Imagine an additional pod or two. This goes back to the fungicide timing. What we found was using a combination of a fungicide and a foliar. By the way, my favorite foliar with soybeans is monopotassium phosphate. You guys are familiar with MAP, monoammonium phosphate. With MKP, what they do is they kick out the ammonium and they put it back with potassium. It's very common in greenhouse use. I heard someone was here from NutraAg. It was actually their product that tipped me off first. It was a product called KP Plus. Absolutely love it. If you want to try something interesting on your soybeans, try KP Plus just before you can see the first pod. That seems to be the best time. Another challenge, and someone gave the answer away earlier today, and I couldn't believe it that someone had actually shared this. Soybeans versus corn, which one likes the warm temperatures? Everybody always tells me that corn is the warm weather one, right? It's actually soybeans. Soybeans like more heat. They can actually tolerate more heat, especially in the reproductive stage. So trying to get more heat during the reproductive stage on soybeans, obviously we can't control the weather, but it's very interesting to be thinking counterintuitively to what we thought we knew. And this is the great thing about data, is it's truly challenging what we think we know. Okay. After you figured out to challenge yourself and beat yourself up as an agronomist, and if you think you're pretty knowledgeable at this point, now it's the fun time of being able to challenge your clients and the farmers. See what they know. How many people have ever worked with a hydraulic downforce planter? Yeah, okay, I've seen a couple hands go up. Okay, I had a large, this is about a 400-acre field. I have a very large client, and he has 2 DB88 corn planters, 22-inch spacing. So for those of you who are not in the know, that's 48-row corn planters. And they have 2 of them, one with hydraulic downforce, one with pneumatic downforce. And so he wanted to know which one would make more sense. So this was the field. What I'm showing you here is an elevation map, okay? The red is low, the green is high. So that's how we split up the field. Was the green had the hydraulic downforce, the red did not. And here is the actual results. So in the heavier soil, that lower ground, we identified it as heavier soil, the downforce won by 7 bushels. This made absolutely no sense, because when you went out and walked the field, the lighter soil, where the regular planter had, the non-hydraulic planter had gone, it looked like, in my eyes, what a potato field would look like. You had these huge ridges, just because these giant planters are sinking so deep in there. But where the hydraulic downforce was, it had lifted it up a little bit, and it didn't look as bad. So I thought for sure the lighter soil was going to be a huge win, and so did the grower. So when he's seen this, he's like, that makes no sense. You reverse the numbers or something, Aaron. So what we did was we took a high-definition aerial image, and now you can start to see some of these lighter areas. This is sandier soil. Some of this is eroded knolls. Got a little tricky when we had to correct for the 2 different zones, but we added all this in, and we got this. This is a response curve based on the soil type and what the corn yields were. So this was the eroded clay. You can see the standard did quite a bit worse. The loam, once again, same as with the eroded clay, the standard did a little worse. It wasn't until out here. And everyone says, okay, what in the world's going on here? Eric, I love picking on Eric because I know he's here. Eric, what's the good depth to plant corn? 2 inches. Now, on an eroded clay, this farmer's having a hard time punching that soil in past 2 inches. On the sand, it's probably down 2.5 inches, but it's sand. It's not like it's going to have trouble coming up. So it still comes up in the sand, right? But the sand soil, okay, that's when you start to run into drought conditions. So that's why the far end, things go wonky the other way. But for the most part, proving this to the grower, he's got a lot of clay farms. He's got a lot of sand farms. If you got 2 90-foot planters, trust me, you got a lot of land. And what he decided was complete opposite to what he'd been doing with these 2 planters before that. Prior to that, the hydraulic planter was used on the sandy soil, and the non-hydraulic planter was used on the heavy ground. After this trial, he reversed it. All right, tillage. My father started no-tilling in 1986, okay? Tillage is a 4-letter word. Eric, would you describe my father as a militant no-tiller? Yes. He is your militant no-tiller. And I got a chance to work with a lot of farmers, and I was talking to one younger farmer who farms with his dad, and he said, hey, Aaron, I've got this farm, and I don't know what's wrong with it, but we just can't get it to yield properly. It's always throwing out weird numbers. And this is one of his yield maps. This was the corn map. And he said, nobody that we've talked to, no agronomist has been able to figure it out. We've tried cover crops, we've tried fertilizer, we've done variable rate, we've done all this soil testing, and nothing's been working for us. I'm like, sure, send it all over and I'll take a look at it. I came up with a whole bunch of theories and ran them by him. He goes, nope, tried it, nope, tried it, nope, tried it. There's his soybeans. Right? There's his wheat. Wheat's not quite as bad, but you can still see it. And you can see that there's a pattern here. And so I looked at it and I go, you know, I think you might have subsoil compaction. He goes, nope, no way. We've owned that farm since 1989, and it has never seen tillage. We have no-tilled ever since we bought it. There is not a chance that it is compaction. Okay, I went out with my handy-dandy compaction meter. Okay, folks, this is a shock. I'm a big fella. I couldn't get that probe in past 7 to 8 inches. That was it. It was done. So now I go to this young farmer and explain. I'm like, it is definitely good subsoil compaction. He's like, okay. He calls up his dad and put him on speakerphone. And Tyler, the young farmer, says, hey, Dad, that agronomist I told you about, he came out, he looked at the field, and he says it's subsoil compaction. I don't know where you got that agronomist, but that guy does not know a clue what he's talking about. So I convinced them to try an inline ripper, right? And this is the inline ripper after 200 acres, okay? By the way, those shanks, I actually had to double check this, okay? That is not 1/4-inch plate steel. That's what I thought it was. That's 3/4 inch plate steel after 200 acres, okay? You can see where that compaction layer is. We found out that prior to them owning it, there was a sand layer in this farm, and prior to them owning it, it had seen a lot of processing vegetables. And when those processing vegetables had to be planted, it didn't matter. If it was raining, they got planted. When they had to be harvested, it didn't matter. They had to come off. So there was this compaction layer down there. Just was insane. Let's face it. If a guy my size cannot get a pentiometer through there, that's something else. But when he shared these pictures, and by the way, he shared these pictures with me when I was at the Windsor Airport coming to you guys, so you're the very first ones to see this slide. Actually, no, I sent it to my dad, just to give him a hard time. So, we did the first pass, and here is the following crop. So there's that corn map, before and after, so the following time. There's the soybean map, the next time we had soybeans in there. And there's the wheat map. Now, it's not perfect. We know that. And so we actually ran on a 90 degrees a second time this past year. And that's actually those pictures that you've seen. So those pictures, that field had already been done once. They actually owned that inline ripper. You don't want to know what it looked like that first one looked like when they returned it to the dealer. Okay. Please do not everybody run out and buy an inline ripper. And by the way, if Brian is still in there, yes, we put a cover crop down as soon as we ran the inline ripper. Just to, yeah, there you go. So we made sure to stabilize the ground. Please go and invest in one of these before you invest in an inline ripper. Like Brian said, what was it, 75% of guys don't see a value? It's because they just assume they have it in there. Go and run one of these. Make sure that that's what your problem is. You might not have to do it across the entire field. It might just be the headlands that you have to do. Invest in one of these. Or talk to an agronomist and get them to invest in one of them. All right, what is the lowest phosphorus test you've ever seen? I love this one. Welcome to a soil test level of 1. Okay, now in Ontario we use bicarb, which doesn't quite translate to Malic 3. 1 is very, very, very low. By the way, that line that you see there, that is a cropping history, more vegetables grown, and actually some potatoes in this part of the world. Eric, this is around the Thedford Marsh. And so where that blue is, history of fertility. So he wanted to know about putting dry starter on his corn planter. So there's the starter fertilizer program. All my little check blocks scattered all over the place. There's the response curve, right? You can see right around about 125, 130 pounds per acre is the sweet spot for this particular farmer. But when we split it out based on high productivity and low productivity, even low productivity, around 75 pounds, showed a response. And in the low productivity, it was closer to 175. So this is the fun stuff that you can start doing with data, right? It's not necessarily easy to do this stuff with data. It's why I've got a job. My whole business model is around farmers have all of this data. They need someone to help them with it, right? Farmers get sold these data platforms. Oh, it's easy. It's not easy unless you're doing it every day. It's with anything. It can be challenging. So partner with folks that can make your life a little bit easier. Soil test. Please, please soil test. I put this as lesson number 5 just so that way I wouldn't get thrown out of the room. It probably should be lesson number 1. Please soil test. Bulk sampling, I'm happy with bulk sampling. When I came back from the University of Guelph in 2001, I asked Dad, I said, hey, where's the soil tests? He dragged them out. They were from 1984. Dad, these are 17 years old. Why? Well, that was when the government stopped paying for them. That's thrifty, right? So if you had a 100-acre, Patty Ann probably knows my father, right? You can get into grid sampling. I love grid sampling. Gives you all kinds of data, whether it's 2.5 or 5 acres. One of the challenges with grid sampling is that you're starting to use the computer to interpolate what's going on. It gives you better definition, but how accurate that definition is, could be questionable. So then we got into these zone samplings. It depends where you are. In Ontario, a zone is 2.5 to 5 acres. If you go to Saskatchewan, a zone is 160 acres. Very different in Saskatchewan, so be careful what you say when you go out to Saskatchewan. But basically, you're predefining them so that you don't let the computer interpolate them. And so now you start to get a little better definition again. And then, of course, there's all the soil sensing work. I do work with soil optics. I'm not saying that's the best one. That's the one I use. I'm a data nerd. Soil optics gives me lots of data. There's SWOT maps, great tool. I've worked with some SWOT map data. I've worked with Veris. It really doesn't matter. It depends on what you're trying to achieve. If you want to get into deep, deep data layers, yeah, maybe you need to go soil optics. But if that's not what you want to do, stick with SWOT maps, right? Go with what is going to make you money. You guys starting to recognize something? I love this. This slide deck shows up everywhere. And sometimes I even get credit for it. Okay, so soil testing. So understanding interpolation. Those are if you had your grid points. This is if you plug that into the software and the software interpolates what's going on. This is one of the challenges with grid testing. It's not bad. I would argue it's better than bulk sampling. There's my zone samples that I drew ahead of time and sampled according to, and they were drawn based off satellite imagery or yield data. There's all kinds of different ways to do it. There is the soil optics map. You can see that, yeah, they kind of make sense, but just adding more resolution to the picture as you go along. All right, Brian, you're gonna love this. Okay, my dad has been militant no-tiller. We've got a farm. It hasn't seen tillage for 16 years. A bunch of cover crops have gone in there. And we go out and we soil test. Okay, 0 to 2 inches. I realize Malik's not on there, so use your imagination that it's somewhere between the bicarb and the brave. But between 0 and 2 inches, between 22 and 30 parts per million on phosphorus. Drop down to the next 2 inches. So this is 2 to 4 inches. 5 to 7. That is a big drop. 4 to 6. 3 to 2. Even bigger. All right, you guys remember what Eric said? Good depth of planting corn is 2 inches. Okay, if you plant at 2 inches, which way do corn roots grow? I'll give you a clue, not up. They go down. So they're going down into this lower phosphorus soil. Okay? There is no way in the world my dad should be able to pull 225, 250 bushels per acre off this field, yet he consistently does. And I think what's going on is it's the mycorrhizae. Brian, you can tell me if I'm wrong or not, but it's pulling some of that phosphorus from down, and it's pulling it down into that rhizosphere. Last one, lesson number 6. Okay, always be thinking about different opportunities. This is the newest one that I've started to work on with the guys that I consult on, and it's net nutrient tracking. And what I'm doing is I'm taking all the variable rate fertilizer applications that we've done based on soil testing, and we're taking all of the yield maps, so figuring out crop removals, and then we're combining them over 3 to 5 years to see what parts of the field are mining and what parts of the field are building. And so that way we can continue to customize what our variable rate fertilizers are going to look like. So the one on, let's see, this one, that is phosphorus, and this one is potassium. So it allows us to customize this. These are the things that farmers are like, finally, something that my data is being used for that's helping me. One last tool, I call this the so what tool. What we did was, so this is, you can do it with different soil type or soil testing data. This one we're going to use polygons. And what we did, this is actually a sulfur trial. And we put different sulfur rates. It's actually technically timing and rates, but we'll say different sulfur treatments. And what we were able to do is you take a look at the data, and if you have it, you heard earlier this morning, if you have the right algorithm, and I have come up with this algorithm, and it allows farmers who have the data, plug it into my algorithm, that's how I make money, I'm able to tell them where in that field it's more or less likely to work based on that different sulfur treatment. So once again, it's customizing to them. You don't have to use my algorithm. There's lots of other ways you can do it. It's your data, right? Last slide. What are the 7 most dangerous words in business? Come on. Yeah, perfect. We have always done it that way. I'm up here to encourage you to challenge how you think, how your farmers think, right? If you think you've got all the answers, Mother Nature has a surprise waiting for you. All right, here's my contact information. If you try to Google me, and find my website, you will not find a website. You might find social media posts and whatnot. I don't have a website. I do it by just through different farmers, talking to different farmers, saying, hey, if you want to talk to a crazy guy about data, I know a guy down in Chatham who'll talk to you all day long. All right, that's what I got. And 1 minute to spare. I'm going to be hanging around tomorrow as well, so I've noticed you guys are all really, really shy, so that or you just don't like people from Ontario or Iowa. Feel free to stop and chat.